Okay. So for today's introduction, I will give you some update about our product, name fresh market, and also some product roadmap. Okay. So first, I will start from the market status. I believe you guys are seeing a very crazy DRAM market now, but actually also same as a fresh market. Okay. So actually it starts from the end of 2020 and it getting worse this year due to overall supply unbalance, especially like wafer output and also IC package and test industry. If you watch some news early this year, in February, Samsung's factory in Austin, they got some power outage, and it caused very serious controller shortage as well as the overall SSD output, because that facility is mainly for Samsung's controller manufacturer, and because of that, so overall, it pushed the order to other vendor and result in a very serious shortage. Also, because of TSMC, their legacy geometry, let's say bigger than 40 nanometer, for example, 50, 55 nanometer, it's their legacy geometry, which means the output is less than their major technology. And it also results in some shortage. For example, for some old flash controller like a USB, SD, or even like a eMMC, these controllers, they use older technology to manufacture. So that's why overall markets shortage start from controller. And also for fresh market, because of demand keep increasing. For example, eMMC for lots of ARM-based platform, and also because of increase in recognition rate, so also lead to an increase in inventory demand. And of course, everyone still work from home, so whatever laptop, gaming, still very high demand now. Also, similar to TSMC, they move some production capacity for newer technology, same as Flash. Okay, for example, our major supplier Toshiba, now they call Kioxia. Actually, they have been moving their production capacity to TLC every year. So now only keep few production lines for MLC. So now the production capacity of MLC is relatively low. That's why you guys may see a very serious shortage and also price increase for MLC. And because of that, it also affects TLC. Even TLC's output is enough, but because of MLC's shortage, so also push TLC's price to increase. So we are seeing this status will keep happening from early of this year and will reach the peak in Q3 this year. So from this chart, you can see the overall market will be in short supply by Q4. Here is a fresh roadmap from different vendor. As I just mentioned, our main source is Kioxia, and currently we are using their 15 nanometer for MLC and 64 layers and 96 layers for 3D TLC. Also, we are testing their fifth generation, which is 112 layers 3D TLC, and it will be available by end of this year. So as you know, NAND flash is another key technology for SSD. So thanks to the new technology, newer 3D TLC not only has higher capacity, faster performance, but also lower power consumption. Here is a comparison table in between 3D TLC and MLC. Maybe some of you guys still tested to try 3D TLC, or maybe you still worry about the quality. But actually, the 3D TLC is different from the previous we call 2D TLC. Okay, so for 3D TLC, it has newer technology. Of course, it does need some technology to support. For example, ECC engine. Because of the 3D TLC, it has some, for example, wall line short issue, or some technical issue need controller to support to fix it. So that's why 3D TLC it requires LDPC ECC engine. For MLC, it only needs BCH, okay? But for 3D TLC, it requires LDPC ECC engine. Also, to prevent data loss and ensure the data integrity, for 3D TLC, all of our products also enable what we call direct function. So we build a RAID by each NAND flash block to, it's kind of RAID file, okay, to back up to ensure no data loss. So also for the 3D TLC, the vendor, they won't tell you what kind of geometry it is. They only tell you how many layers. So currently we are using 64 layers and 96 layers. Soon we will have 112 layers. Okay. The biggest difference is capacity. So for current MLC with 50 nanometer, I would say it's probably the last generation for MLC, and its density per die is 128 gigabit, which is 16 gigabyte. But for 3D TLC with BiCS5, the latest 112 layers 3D TLC, it can support up to 1 terabit per die. So you can see it's a 10 times different. But in terms of endurance, I think it's the biggest concern for customers. They are hesitating to try 3D TLC. Compared with 2D TLC, the 3D TLC we are using is for industrial application. So we can guarantee 3000 PE cycle, which is the same as MLC. And also we use original Y10 3D TLC. So we also can support minus 40 to 85 degrees C. For product warranty, we offer the same warranty, 3 years. And another one I think is quite attractive, which is cost. So compared with MLC, the 3D TLC price is much lower. So it let customer easier to replace from previous whatever SLC or MLC or even traditional hard drive to 3D TLC. Here, I use Kioxia 3D TLC as an example. You may be curious what is BiCS, B-I-C-S. Actually, BiCS is their term for 3D TLC technology. And because Kioxia and Western Digital, they share their foundry. So both of them use BiCS as their 3D TLC technology name. And currently we are using BiCS3 and BiCS4 as our main source. Soon we will have BiCS5 available. As you can see from the table, by increasing layers, the density of NAND flash keep improving. Also, the data rate is constantly improving. Here I take BiCS5 as an example. Its density is 1 terabit per die, and we can pack at least 8 dies in a package, which means a single NAND chip can support up to 1 terabyte, which means M.2 SSD can up to 4 terabytes, and with 2.5-inch form factor, it can support up to 16 terabytes. Regarding the performance, by using BiCS5 NAND flash with PCI Gen 4 interface, the performance can reach up to 7.6 gigabytes per second. So to improve the performance, not only rely on controller, but also the NAND flash. So with the newer technology, especially 3D TLC, as I said, it's not only increase the density, lower the cost, but also improve the performance. So, for example, SATA, the max performance may be only up to 180 megabytes per second, but with PCIe Gen 4 plus the newer 3D TLC technology, you can reach up to 7.6 gigabytes per second, which is almost the limitation of PCIe Gen 4 bandwidth. Okay, so maybe you guys are interested in NVMe, or maybe you are using it. So NVMe stands for non-volatile memory express. Obviously, it can be understood from its name that it is a protocol defined for non-volatile memory. Since it's a protocol, so it needs an electronic interface to communicate with CPU, DRAM, such as PCIe, private channel, or Ethernet. Here are some comparison in between SATA and NVMe. First, SATA transfers data at half duplex, while NVMe transfers data at full duplex. So it can read and write data continuously. In addition, as you can see from the chart, NVMe communicates directly with the CPU. It efficiently reduces the latency, which is another weak point of SATA interface. In this page, you can see the bandwidth comparison in between SATA and PCIe. As you know, the bandwidth of SATA 3 interface is 6 gigabits per second, which means the theoretical transfer limit is around 600 megabytes per second, and its latency could up to 200 microseconds, and only support 1 queue with max 32 commands. For PCIe, most spec is Gen 3 now, and Gen 4 is gradually popularized. So I'm using Gen 3 as an example here. Its bandwidth is 8 gigabit per line. So for example, M.2 SSD with 4 lanes, it can support up to 32 gigabits per second, which is 4 gigabytes per second. So it's 8 times than a SATA SSD. And its latency is much lower, around 3 microseconds. Moreover, it can support up to 64K queue and 64K commands for each queue. But of course, it's a theoretical spec. A real example is our developing Gen 4 SSD. It can support 256 commands per queue and up to 132 queues. So you can understand how's the gap in between NVMe and SATA. There are many form factors with PCIe NVMe interface, including add-in card, 2.5-inch, M.2, CF Express, and the BGA SSD. But add-in card is mainly used in enterprise storage. So for industrial PC, IoT, or embedded system, customers prefer smaller form factor like M.2 or other smaller form factors. First is M.2. I think it's quite popular now because it's already kind of mainstream with SATA interface, but it also can support PCIe interface. So not only multiple interface, but also different form factors, including 2242, 2260, 2280, and 22110. So board maker can design M.2 with different lengths, and because of its compact dimension, it's very suitable for various systems, especially those systems you care about the mechanical interference, or you need some horizontal design. Then M.2 is the best solution. Another one is U.2. U.2 is 2.5-inch form factor with PCIe 4 lanes. So it can support higher capacity, So it's more suitable for like data storage or some application you request both high performance and high capacity. The third one is CF Express. As the name shows, it's a form factor defined by Compact Flash Association. It supports PCIe 2 lanes, and the dimension is a little bit bigger than SD card and smaller than Compact Flash card. So if you play Xbox, the expansion card launched by Seagate for the latest Xbox, actually it's CF Express inside. It's a very good for those applications that request higher performance but also need a quick swap. So CF Express would be the best choice for this kind of applications. Also, it's very popular now for some high-end digital camera. Okay. The last one is BGA SSD. I believe it's the most compact NVMe device, and also it's a part of M.2 family, including 11 by 13 and 16 by 20 form factors. So comparing with other common BGA storage like eMMC, this product is support much higher performance and features. For applications that require small footprint or extremely high reliability, then this will be the best choice. So for our PCIe product, including Gen 3 by 2, by 4, and also we are developing Gen 4 solution. So provide different form factors with different performance. First one is Gen 3 by 2 and by 4. As I just mentioned, we are providing U.2 CF Express and M.2 form factors. So it's up to 2 terabyte capacity with 3D TLC, and can provide up to 3.5 gigabyte per second for the performance. And it supports NVMe 1.3. Also, in case you need like AES TCG OPO or some additional like extra capacitor for the abnormal power cycling solution. And also we do have a technology called ISLC. It's a kind of in between of MLC and SLC. So we can transfer the 3D TLC to work as a SLC to get much better endurance and performance, but cost is much lower than SLC. Also, Gen 4 solution is available by Q3. So it will support up to 4 terabyte, better performance, and support NVMe 1.4. And by end of this year, we are going to have Gen 4 by 4 product and support higher performance, up to 7 gigabytes per second. And it supports NVMe 1.4, also AES and TCG OPO. In case for some special application, for example, security or military application, our product also can support different security erase standard. Okay, so in case customer they have some bidding project or they have some special request for the project, then we can support it. The last one is for SATA. I believe even NVMe is becoming getting popular or becoming a mainstream product, but I believe SATA interface still will keep in this market for a while because of its cost, its reliability, and its multiple form factors. Okay, so for SATA interface, we are still providing so many different form factors, including 2.5 inch, 1.8 inch, M.2, whatever, 2242, 2280, SATA, and CFast. So with these form factors, also available with SLC, MLC, or 3D TLC NAND flash, and up to 4 terabyte with 2.5 form factors. In case you need a wide temp, -40 to 85, also available with all product lines. And of course, AES, TCG OPO, or security erase function all available with our product. Okay. Thank you. So is there any question about today's presentation?
I have not received any questions myself, George. And looks like we have one. Go ahead, Andrew.
I'm trying to think of the right way to word the question, so give me 1 second.
Take your time.
Okay, I guess it's more of an NVMe conceptual question, just for my understanding. Going between the different generations of NVMe, the actual PCI slot itself, does that change? Is there like a motherboard to NVMe like compatibility that we would need to follow, or as long as it has that PCIe slot, that is it just like that's the standard PCI slot for NVMe?
Yes, you don't need to worry about that because it's more rely on CPU. So the
Okay.
PCI connector is just a physical connector for our device to connect to your motherboard. Okay, so
Okay.
so
none of the iterations of PCI change the actual physical plugin, because I've seen that with a lot of the iterations of different RAM and different upgrades in that area. The actual connector changes, so it makes the older versions not work. But if the connector is the same, then it should all work fine.
Connector is the same, whatever Gen 3 or Gen 4, but the only difference in connector is like by 4, by 8, by 16, right?
Okay,
but,
so
yeah. So physically that's the same, but it depends on your CPU. For example, the AMD Ryzen CPU, they support Gen 4 now, and Intel also come in. So it all depends on your CPU.
Okay.
Yeah.
Perfect. That was really my main question.
Yeah, and even you are buying a Gen 4 product, but your motherboard only can support Gen 4, it's fine. You will backward compatible.
Okay. Yeah. That answers my question. Thank you.
Okay, no problem.
Yeah, I'm good. I don't actually have any questions, but thanks for the presentation.
Thank you, Richard. With that, George, it looks like we lost one audience member right at the end of the presentation. Randy, did you want to add anything?
No, I'm good.
Okay. With that, gentlemen, I thank you for your time today. George, that was a very good presentation. Very informative.
Thank you, George.
Yeah, definitely. Thanks, and have a great day.
Yeah, thank you, gentlemen.
Thank you.